We're going to start with some addition chain rules. There are 3 rules that all addition chains must follow. So first, it starts with 1, it ends with n, and every number in between except the first is a sum of 2 previous numbers. So I'd like to clarify that this addition chain is the exponentiation case. Let's start with an example. Base 2 addition chains. Okay, let's say you have something like y to the power of 100. And here, this 100 value here is the n, which we were talking about in the second step. You want to get the addition chain for this guy, so we just look at the exponent. Let's write down 100. So as the first rule stated, it always has to start with 1, so we can write 1 on the other end. And it's easier to work backwards from 100 rather than to build up from 1. So we're going to work that way. So what's the first thing you notice? Well, 100 is divisible by 2. So let's try that. Let's divide it by 2. Similarly, 50 is divisible by 2. Okay. And now we stop. 25 is obviously not divisible by 2. But 24 is divisible by 2. Now, why was I able to write down 24? It's because 25 minus 1 is 24. Which means 1 plus 24 is equal to 25, which satisfies the third addition chain rule. All right, let's move on. Keep dividing by 2 until you can't anymore. All right, we stop. Now we got 3. The number closest to 3, which is divisible by 2, is 2 itself, and then we can just move 1 up here. This is the addition chain for base 2 of y to the power of 100. Let's make sure that it's correct by going from the smallest number to the largest number. You can make sure it's correct as long as it follows rule 3. So 1 plus 1 is 2, right? The sum of the previous 2 numbers is the next number. 2 plus 1 is 3. 3 plus 3 is 6. 6 plus 6 is 12. 12 plus 12 is 24. 24 plus 1 is 25. 25 plus 25 is 50. 50 plus 50 is 100. Great. Okay. Well, that's good. Let's do something a little bit more different. What if we want to do base 3 addition chain? Okay, let's use the same example so that it's not too confusing. Again, this 100 here is our n. Okay, so what are we going to do? We'll just do the same thing we did before, and we'll start it like this. All right, so now you have 2 options. You should realize, firstly, that you can divide 100 by 2, and it'll still satisfy it in base 3 because it satisfies the third rule. 50 plus 50 is 100, right? Or you could do this. You could subtract 1 from 100 and get it to be a number divisible by 3. So the number closest to 100, which is divisible by 3. Let's try this way first, and then we'll try to divide 100 by 2, a second way later. All right. And what's 99 divided by 3? Well, that's 33. Okay, we'll come across a small issue. There's a gap here. Obviously, 33 cannot sum to 99. So you just have to fill in the gap. The easiest way is to just multiply 33 by 2, because 33 currently is the largest number in the line, which can be summed. Great. Well, 66 plus 33 is 99, so our problem is solved. Okay, moving on. 33 divided by 3 is 11. Again, another gap. We'll just apply what we did previously. That works. Okay, from 11 to... so that would be 9. Notice here, you'll have to go 11 minus 2 to get 9. Keep that in the back of your mind for now. 9 divided by 3 is 3. And okay. So why did I put a 2 here? Well, 2 reasons. Firstly, in order to satisfy the third rule, 1 plus 1 can only ever equal 2. So it kind of needs to be there always. And secondly, we need this 2 again when we want to do 11 minus 2, or in this case, I guess 9 plus 2 is equal to 11. Okay, hopefully this will make sense when I go from the smallest number to the biggest number. Like I said, 1 plus 1 is 2. 2 plus 1 is 3. Oh no, we have a problem here. There's actually a gap. We can fill it in. We'll just put a 6 here. 3 plus 3 is 6. 6 plus 3 is 9. So this is why it's really important to check your work backwards and forwards. Okay, 9 plus 2 is 11. 11 plus 11 is 21. 21 plus 11, 22. 22 plus 11 is 33. 33 plus 33 is 66. 66 plus 33 is 99. And then 99 plus 1 is 100. Okay, cool. That's great. This is a very valid addition chain. What about the second method that I discussed previously? Let's try that. Okay, we have 100 and we have 1. Let's divide 100 by 2, get 50. Divide it again by 2 and get 25. Okay, now we stop. Obviously, 25 can't be divisible by 3. So what's the closest number to 25 that is divisible by 3? It's 24. Now, what's 24 divided by 3? It's 8. Okay, let's fill this gap. Probably just multiply 8 by 2, and then 16 plus 8 is equal to 24. Okay, and the closest number divisible by 3 to 8 is 6, followed by 3, and then 2, and then 1. Okay, let's check if this is correct. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 3 is 6, 6 plus 2 is 8, 8 plus 8 is 16, 16 plus 8 24, 24 plus 1 25, 25 plus 25 50, 50 plus 50 is 100. So here is another perfectly valid addition chain. But notice the length of this addition chain is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. But what's the length of the previous addition chain? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Huh. Okay. Although there are multiple ways to solve addition chains, and there are some ways that are slightly better than other ways. For example, dividing by 2 right away will actually save you one step in your addition chain. Let's try another example and see if it works. Base for addition chains. Again, let's use our handy dandy number here just to be consistent. Wait, 100 is actually divisible by 4, so let's do that. Okay, great. Again, here's a big gap that we need to fill. How shall we fill it? Oh, well, okay, that was pretty straightforward. The number closest to 25, which is divisible by 4, is 24. So we'll move that there, and then we'll divide 24 by 4, which gives us 6. And we're going to fill in this gap by putting in 12. Again, 6 plus 6 is 12. And then we can close off here. And there's a gap here also. But of course, we know we should be putting 2 here anyways. Let's move up the chain and see if everything is good. 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 6 is 12, 12 plus 12 is 24, 24 plus 1 is 25, 25 plus 25 is 50, and 50 plus 50 is 100. Great, we have a valid addition chain. Let's try it with the second method, where we divide by 2 outright. I'm just going to write it down because I hope you see what's happening. The length of these addition chains are the same, although not all addition chain values are the same. See, in this case, I have a 3 because 6 divided by 2 is 3. So, well, what's the difference between step 1 and step 2? Well, step 1, it prioritizes numbers divisible by the base. And step 2, or method 2, I guess, prioritizes numbers divisible by 2. Okay. In my opinion, step 2 is better because you just divide by 2 outright. But step 1, you actually have to do one subtraction step and then finally another division step by the base. Keep that in mind when you're doing addition chains. And I'd like to say there's a magic way to solve any addition chain, but actually, addition chains are a non-polynomial problem, and there's no special way to solve them. There's no special calculator, so you just have to kind of do it yourself. I hope this video helped you understand how to sort out addition chains with different bases in a clear manner. Give a thumbs up if this helped you out, and leave a comment in the comments if you have any questions or want me to clarify anything in the future.